Okay, and welcome back to the second set of our sample problems. I had my tablet fixed, so we can now continue without any disturbances in the writing process. Okay, so let's resume. If the pediatric dose of chlorothiazide is 10 to 20 milligrams per kilograms of body weight, what is the minimum and maximum dose of a child if he weighs 48 pounds? So in this case, you need to have a range. You are looking for the range of the dosing. So it is 10 to 20 milligrams, okay, per kilogram body weight. So you need to simply multiply 10 milligram per kilogram and 20 milligram per kilogram. However, the patient's weight is in pounds. Okay, simply put, 48 pounds 48 pounds times 2.2 pounds is 1 kilogram. 1 kilogram is 2.2 pounds. Okay, so kilograms, pounds, kilograms. So let's see. 10 times 48 divided by 2.2, 218.18 milligrams, and 20 times 48 divided by 2.2, you have a 436.36 milligrams. So this is your range. This is the minimum dosing. This is the maximum dosing. So some questions will ask you if a drug is overdose or underdose depending on the range of dosing. So cyclosporin is an immunosuppressant administered before and after organ transplantation at a single daily dose of 15 milligrams per kilograms. How many milliliters of 50 ml bottles containing 100 milligrams of cyclosporin per milliliter would be administered to a 140-pound kidney transplant patient? So this is a computation that needs both patient dosing and concentrations. Okay, let's start with the patient's weight. 140 pounds. The dosing is in milligrams per kilogram, so we need to convert it first into kilograms. Okay, so that would yield kilograms multiplied by the dosing, 15 milligrams per kilogram. Okay, so the dose is actually 140 divided by 2.2 times 15. You have a dose of 954.54 milligrams, and it's pretty large. And how many milliliters of 50 ml bottles containing 100 milligrams of cyclosporin per milliliter would be administered? So since the concentration is 100 milligrams per ml, simply divided by 100, you need 9.5545 milliliters. Okay, now you need only around 9.5 milliliters. However, one bottle is 50. So 50 is greater than 9.54. You only need one bottle of 50 ml. Okay, it is asking for how many bottles. Next, a physician desires a dose of 40 micrograms per kilogram of digoxin for an 8-pound newborn child. How many milliliters of an injection containing 0.25 milligrams of digoxin per milliliter should be given? Okay, so the dose is 40 microgram per kilogram. Next is an 8-pound newborn baby. Please take note, class, that I'm converting as I go. Kilogram, 40 times 8 divided by 2.2. So you need 145.45 micrograms. How many milliliters of an injection containing 0.25 milligrams of digoxin per ml? Now the problem is this one is in milligram per ml. So you need to convert it first to microgram. 1 milligram is 1000 micrograms. Okay, these milligrams. Oh wait, there's an error. Okay, let us first convert 0.25 milligrams per ml of digoxin to micrograms. 1 milligram is 1000 micrograms. We will have 0.25 times 1000. It is 250 microgram per ml. Okay, you're going to multiply it here. 250 microgram. This is microgram per ml. So 145.45 divided by 250, that is, you only need 0.5818 milliliters of injection. So half an ml would be injected. So next, if the dose of paclitaxel in the treatment of metastatic ovarian cancer is 135 milligram per meter square, what would be the dose of a patient 155 cm tall and weighing 53 kilograms? So this time, the dosing is 135 milligram per meter square. Now the problem is we need the patient's BSA. Okay. So to get the BSA, square root of 155 cm multiplied by 53 kilograms over 3,600. Please take note, class, you should finish all the equations inside the square root before squaring or getting the square. 155 times 53 divided by 3,600. Get the square root of that. So the patient's body surface area is 1.15. So let us multiply it by 1.51. 135 times 1.51. The patient's dose is 203.85. Okay. How many capsules, each containing 250 milligrams of clarithromycin, are needed to provide 50 milligram per kilogram per day for 10 days for a person weighing 170 pounds? Okay. So first is, let's get the weight of the patient. 176 pounds times 2.2 pounds is 1 kilogram. Okay, so the patient's weight is 80. Now, the dosing is 50 milligram per kilogram per day, and it is 10 days. Kilogram, days. 80 times 50 times 10. Wow, you actually need 40,000 milligrams. Okay, and the capsules are 250 milligram per capsule. So divided it by 250, you need 160 capsules. A high-dose treatment for osteosarcoma includes the use of methotrexate at a dose of 2 grams per meter square at a 4-hour intravenous infusion. For a patient having a BSA of 1.7 meters square and weighing 162 pounds, calculate the dose on the basis of milligram per kilogram per minute. Okay. A bit hard, but let's do it. Okay. So the patient's PSA is 1.7. Okay. You actually need okay. Let's first get the dosing of the patient first. 12 grams per meter square times 1.7 meter square. So 12 times 1.7 get 20.4 grams. That's a lot. So 20.4 grams is to be divided over, it is to be administered over 4 hours. Let's simply divide it by milligram per kilogram. So let's convert this to milligrams. 20,400 milligrams. And that's divided by the patient's weight, which is 162 pounds. 162 divided by 2.2. So the patient's weight is 73.64 kilograms. Okay, then over 4 hours, all over 4 hours. But since the problem is asking for minutes, 1 hour is 60 minutes. Okay, so this is actually 4 times 60, 240. So in the end, we would get the correct units: milligram per kilogram per minute. 2400 divided 73.64 divided by so the dosing is 1.15 milligram per kilogram per day. Okay, I actually had difficulty with this problem. Next, so there's no more next question. I would also be uploading another set of sample problems for you to practice. So I hope you understood the lesson. This should be easy for you, and I hope you take time to practice solving the problems.